Now, yeah, coming to this pixie. So again, it doesn't mean that all the sperm where you see the head shape is normal and the typical normal sperm, no, actually doesn't mean that they really have a very good DNA in it. Because sometimes the good sperm, what we say the morphologically good sperm, do have certain DNA defect. That when you do an ICSI procedure, you just can't make out that which sperm is having a very good DNA and which sperm having a defective DNA, though they have a good morphology. Now, what is the alternate for it? The alternate procedure for that is a PIXI. This is like a specialized sperm selection method. This is based on an enzyme reaction. On the left side, on the top side, you can see A, B, C. So this is called a pixie dish. On the first picture, where you can see an arrow. So above that, there is a medium, which we call hyaluron. So the sperm head will have an hydrogenase enzyme, which will react here, and then it will, what it does, it will clears the, what you call it as, it will clear the zona, especially the cumulus complex. So when they eat up the cumulus complex, what it says is, I'll tell you an example. Now there is an IVF procedure where we collect the oocyte. When we collect the oocyte, we subject the sperm to it in a conventional IVF. So those sperm which has a good acrosome activity, which in turn the sperm which have a good hyaluronase activity, they'll eat up the cumulus and make its way to enter into the core where the oocyte is there. So they will fertilize. So this is a natural selection for a oocyte in order to make sure that it select a good sperm which has a good DNA in it. Now in an ICSI procedure, we can't do this thing because the limitation in ICSI procedure is we select the sperm based on a sperm morphology. That's the limitation. That's the extreme thing which we can do it. But the good morphologically selected sperm doesn't mean that they are genetically stable. So now PIXI is one of the helping method for an embryologist to select the genetically stable sperm. But again, it's not 100%, but it is better than an ICSI procedure. So what happens here is, the arrow mark which you're seeing, you have an hyaluron medium in it. Now, the sperm, as I told you in a conventional method, how a oocyte will fertilize the egg. So the sperm, the sperm have head, but don't have any brain. So how do we manipulate it? It is in our hand. So when the sperm are subjected to this hyaluron medium, what happens is the sperm thinks that it is attacking the cumulus complex. That is, it is about to fertilize the oocyte. So what happened? The sperm, you can see here on the bottom, all the sperm head is bounded in a hyaluron medium. So that means what is happening here is the hyaluronase and hyaluron activities is happening. That means the sperm thinking that it is attacking the oocyte, but actually it is there on the dish. So in PIXI procedure, what we do is those sperm which is having this action, we take this particular sperm and inject that into the oocyte. Because this says that when the sperm shows this kind of action, where hyaluronase activity action, generally their DNA content will be good. But again, in this procedure, you will have some free moving sperm. Though the morphology is good, they keep moving freely. Those sperm we will not select it. But in regular ICSI procedure, we just select a random sperm where we feel the morphology is normal. But in PIXI, we selectively select the sperm where it shows this hyaluronase activities. Okay, so by this we can, to a certain extent, we can make sure that we take the sperm which are genetically more stable. Okay, so this is a video. Okay, you can see here the sperm in the middle and the periphery. There are a lot of sperms which are attached, and there are some sperm which are free moving. So though their morphology is good, they are free moving and they're not attached to the hyaluron. But those sperm where the hyaluron is, those sperm where they are attached to the hyaluron activities, so that will be selected Okay, those sperms will be taken inside our ICSI needle, and then we do the immobilization. So we leave all the sperm in a PVP medium, and then here we will immobilize them and take them for our ICSI procedure. Okay. Yes, there's one more challenges in order to get a good genetically stable sperm. In PIXI, as I told you, we are selecting a sperm where the genetic content is good. But there's one more activities of the sperm is, we know that all the sperm which is formed in our body at some point of time, they'll die. So understand this concept, which we call it as apoptosis. So every cells in our body has an apoptosis. Similarly, the sperm cells will also have a apoptosis procedure. So the sperm which we select randomly in a PIXI, even in a PIXI procedure, we are not very sure that whether they are newly formed sperm or whether they are in half-life or whether they are about to die. So there are three phases. So the sperm which we are about, the sperm which are about to die, if we take that particular sperm, what is that dying? What is the apoptosis is? Nothing but the nucleus will disintegrate. I mean, the nucleus activities will go down. Simultaneously, the cytoplasmic activities also will go down. So that they'll at some point of time they'll die. When they are in a declining phase, if we take that sperm for an ICSI procedure, at that particular time, we may be happy that they are attached, the head is attached, and they are live, and they are moving in a better way. But within the time frame where when we inject that sperm to an oocyte, it needs some time, at least, may say for example 10 hours for them to exchange this gametes and show the pronucleus. Okay, so 10 to 16 hours post insemination, in case if the oocytes are fertilized, it will form two pronucleus, formed from the maternal side and the paternal side. In case if the sperm dies before it, the fertilization will never take place. Though you have selected the best morphologically good sperm, you have selected a sperm which has a very good DNA, but there is one thing which is lacking is we are not very sure that when the sperm is going to die. So in case if you have taken that particular sperm, again, your oocyte will not fertilize, and then even if it fertilizes, the genetic contents will not be good. Now, what is the alternative for it? Now we have a technology called MAC, magnetic activated cell sorter. So what happens here is, those cells which are about to die, you can see here on the left hand side, this is the cell membrane. You have an extracellular membrane and the intracellular membrane on the sperm. So when the sperms are very young or newly formed sperm. Okay. Now what happened? There is a protein called PS protein, which is there on the intracellular membrane. When the cells are about to die, what happens? All the PS proteins are expressed on the surface, on the outer layer of the sperm. So now this is the mechanism which is happening in the sperm where they are about to die. Now we have an annexin beads, okay, which has a complementary receptor with respect to this PS. So now these beads are magnetic. It's a micro beads. The beads are coated with it's a magnetically charged. So these are coated with the receptor. Now you can see this receptor when they mixed with the sperm mixture. So those sperm where the PS proteins are expressed, they'll come, and because it is having a complementary receptor, those will come and attach to the magnetic beads. Now it's like a trapping all the sperm which are about to die or which is under apoptosis. So now in a tube where we mix these beads along with the sperm concentration, so they mix only the sperm which are about to die, where they are when they are undergoing an apoptosis, they will attach to the magnetic beads. And this meat on the right hand side, you can see. So this once we mix it, we keep for 10 to 15 minutes so that the reaction takes place, and then these are subjected into a magnetic field. You can see there is a capillary or a flow where all this processed sperm is mixed sperm is kept here, and there will be a flow. And those sperm where it has an apoptics, those sperms which are attached to this magnetic bead, they will attach on the wall. On the bottom, you can see because of the magnetic field on the glass. There is a magnetic field. So this magnetic field will, magnetic beads will get attached on the walls of the tube because there is a magnetic force. So on the left hand side, you can see there are some sperm which are free moving. So now these sperms are the sperm which are very newly formed sperm, and the genetic content will be good. So in this way, we can select a sperm where the genetic of the sperm, we can assure that they are in a very good quality. There is one more mechanism. I personally don't depend on this thing much, but still I'm telling you guys so that you guys should know about all this mechanism or the steps or the technologies which we have. So what is this is MFA, that is microfluidic assay. There is one clear information which we have is when we centrifuge the sperm, because when the way we can concentrate the sperm is by the centrifugation. That is the only technology which we have in order to concentrate the sperm. But what happens in a centrifugation forces, you rotate the sperm with respect to 1200 to 1800 RPM. That is rotation per minute. So 1800 rotation per minute will damage the cell wall or even the entire cell, that is the sperm cells. Okay. So there is an evidence. It is very sure that when you spin the sperm with such an highest RPM, definitely they will undergo certain DNA damage, what we call the DNA fragmentation. But without centrifugation, we cannot concentrate the sperm. I'll tell you an example. Say, for example, you are about to do an IVF procedure or ICSI or a IUI procedure. Let us consider ICSI procedure. The sample which you have collected is, the count in that is probably 1 million or occasional sperm here and there, or less than 1 million. But the husband or the couples, they don't want to go for a donor sperm. They want to utilize only their sperm to create the embryo. So in such cases, you cannot just randomly take a collected raw sample and then put it into your ICSI dish where you can select the sperm, because the count is very less. So it is just occasional or less than 1 million. So in such cases, you have to concentrate the entire volume so that your pellet will have at least some sperm. This can be used for ICSI. So the only way to concentrate is by RPM. That is your centrifugation. So during the centrifugation, of course, there are sperm which is collected, and the sperm which you have collected in the pellet will have at least some amount of sperm that can be utilized for a ICSI procedure. So the only ways are centrifugation, right? So you got the sperm. But here, what is happening, though the count is very less, we don't have any choice rather than centrifugation it, but centrifugation again causing the DNA damage. No other choice. But here in this device, on picture here, you can see a device, a device called microfluidic chip. Okay. It has 4 wells. So A, B, C, D. So now what happens is, again, this has some limitations. I'll tell you the limitation first, then I'll make you understand the concept of this. This cannot be used for a count which is less than 4 or 5 million, the raw count. I'll tell you why. Now let us understand this concept. So now well A, B, C, D, you have to add the sperm, raw sperm or a processed sperm, whichever, in well A, and in well B, you have to add the media for it. Now what happens, because of the capillary suction, this entire, you can see this line is primed by the media, your sperm medium. So now the entire channel is filled with fluid. Now the sperm can swim. That is the major concept. The basic principle here is, because of the sperm which can able to swim, what happens, all the sperm which they cannot able to swim will retain here. You can see on the right side. The black one are the sperm which are motile. Okay, so they will be keep moving. So here you can see on the left hand side. So all the sperm will start a journey from here and they'll move in this line. And because of the motility, they will move forward or they move upward, and that will be collected in well C. those which they cannot able to move, they will be all collected in D or will remain here. Okay, so this D well, we will never give an opportunity to take any sperm in it because it has a lot of debris in it. Only the well C where we take the sperm, because the sperm which are collected here in well C, there is no RPM, there is no centrifugation. It's a natural way. This because of the sperm which has an ability to move, progress. Those because of the motility they are collected in well C. So now the sperm which we have collected in well C, we are not subjected them for any RPM, which in turn means there is no centrifugation force which is applied, which again in turn means that there is no DNA damage. So in this way, we collect the sperm. But the major drawback in this procedure is we could able to collect the sperm only based on the morphology, only based on the motility. But it not says that even the motile sperm, we know that there will be certain DNA damage. Okay. Here, the DNA damage which is caused by the RPM is prevented. But it is not 100% sure that the DNA damage which are naturally present in the sperm is not separated. Okay, so this is the principle. But now this is a quite outdated technology. Even we made a lot of research on this thing where evidently we didn't find any major difference in the genetical content of the sperm. But your MAC and PIXI has certain science behind it. Okay, so these two are the updated techniques which we use in order to select the best DNA sperm.